So let's try and analyse the system now. What we're going to do is write an equation of motion for each particle in the system. There's normally going to be two. We're then going to solve those equations to find the acceleration and the tension, which are normally the things we don't know. We don't know how fast the system's moving, and we don't know the tension in the cable. If we have a look at this system, the tension in the cable is going to be the same on either side. Okay, so each tension I have for each equation of motion is going to be the same. And also, because they're connected together, both these particles are going to accelerate at the same rate. So the acceleration here and the acceleration here are exactly the same. Okay. Let's have a look at particle B first. So there's tension even acting upwards on it, and weight acting downwards. Now this 10G, remember that weight is mass times gravity. It's got a mass of 10 kilos. So I've just written 10G for the weight. We can write an equation of motion now. If you look at our arrow, this system is moving downwards. So I'm going to take the 10G as positive. So I get 10G minus T, which is the resultant force, is equal to the mass, which is here, times the acceleration. Okay, so that's just Newton's second law, otherwise called the equation of motion. And that is my equation of motion for particle B. I can also write an equation of motion for A. Now, what forces are acting on A? Well, the only one we're really bothered about is the tension. Now, you may be thinking, well, A's got a weight. It's got a mass of 4 kilograms, so it must have a weight. It does, but we don't care about it because it's acting downwards. This particle is traveling in this direction. Okay, it's being pulled along the surface, and this force acts at right angles to it, so it has basically no effect on it whatsoever. We're only going to consider forces acting in the direction of travel or opposite to the direction of travel. If there was a force acting backwards here, we would consider this, but a weight we don't take account of. The easiest way to remember this is if the particle is traveling horizontally, we don't need to take account of the weight. If it's traveling vertically, we do need to take account of the weight. So it's really easy for this one. The resultant force is just T. There's no other forces acting on it that we're interested in. And we've got F equals ma. There's the mass. There's the acceleration. And there's another equation of motion, but for particle A this time. So here's my two equations of motion. Now the things I don't know are the tension and the acceleration. Remember, G is just a constant of 9.8. I don't need to solve for that. It's just something I can substitute in later in the question. So basically we have simultaneous equations here. I'm not going to go over too much about how to solve them. If you're struggling with how to solve simultaneous equations, if you go to the AS Pure Maths section on the Solve4x website, under the algebra and functions topic, there's a lesson on simultaneous equations which goes over solving by elimination and solving by substitution. You shouldn't need to do any substitution solves here, but what I'm about to do is solve by elimination. I've added the two equations together, which eliminates T. And then all I do is rearrange to find the acceleration by dividing by 14. I've substituted in G here. And that gives me an answer of the acceleration is 7 meters per second squared. I can also find the tension just by using that equation again for particle A. I know the acceleration now is 7. 4 times 7 gives me 28 newtons for the tension. Okay, and that's how we solve them. We solve all pulley systems in a very similar way, but just sometimes we have additional forces. In this case, we've got a friction force on the surface. We're not assuming the surface is smooth here, and actually there's a constant resistance being applied. So you can see here there's a 20 Newton resistance between the surface and particle A. Okay, we're going to need to take account of that in our equation of motion. The equation of motion for particle B is exactly the same, except for the fact I've given it a different mass of 15 kilograms. But basically the weight is 15G, the mass times G, and we've got tension again. The resultant force is going to be the weight minus the tension. So here's your resultant force. We've got a mass here of 15 kilograms, and the acceleration is here. So there's your equation of motion. There's one of them, and we've got the unknowns T and A. They're what we're going to figure out. A is a little bit different though. We've got two forces now, a tension force and a resistance force. So when we write the equation of motion this time, we need to take account of both of them. Notice that this particle is moving to the right, so I'm going to take tension as positive, which means my resultant force is T minus 20. Okay, here's the resultant force here. And here's M, which was 7 kilos, and here's the acceleration. And there's my other equation of motion. Now, if I simultaneously solved these two equations, I would find the tension and the acceleration. Okay, we're going to get two equations most of the time when we do pulley systems, and we'll be able to solve for those two variables. Now, another type of pulley system is when both particles hang vertically, so something like this. So we've got a big pulley here at the top. This is the pulley wheel. And two particles C and D. Now, at this point, this is a bit more difficult, isn't it? This direction it's moving in, because it could be moving upwards or downwards. But notice that C is heavier. Okay, so C is heavier, so actually C is going to go downwards in this case, which means D is going to come upwards. And that's really important when we write our equations of motion. Let's have a look at C. There's two forces acting on it. There's the weight downwards. Remember, this is just mg, and m is 4. And the tension acting upwards. It's traveling downwards, so we're going to take that weight force as positive. And the resultant force is going to be 4g minus t. There's the mass, there's the acceleration. Remember that the acceleration is going to be the same on both sides because both particles are connected together. And the tension on both sides of cables is also going to be the same. So let's have a look at particle D now. Again, there's a tension force and a weight force. But remember that this is moving upwards. So we're going to write T minus 3g as the resultant force because we're taking the upwards force as positive. And it's just going to equal to ma again. Okay. Again, we've got two equations here. When we solve them, we can find the tension and find the acceleration, and we'll solve the problem. Okay. Once we found the tension and the acceleration, that's normally the hard work done for a question, or certainly the majority of the work done anyway.